Let us start electronegativity. What is electronegativity? We'll see. See, in the word you see, electro is there, electro, and sign if you say negative, sign is a negative, it is electro. That means electrons, negative charge. That means when negative charge we will get, when we gain electrons. Okay, when species will get negative charge when they gain electrons. That's why their name is electronegativity. Set. This electronegativity word is applicable for bonded molecules. This electronegativity word is applicable for bonded molecules. For bonded molecules only it is applicable. So electronegativity means first we have to take which one, in the sense bonded molecules we have to take. In the bonded molecules, in the sense whether we have to take a covalent molecule or a ionic, covalent bond we have to consider, or ionic bond we have to consider. Anything we can consider, because ionic compounds have ionic nature as well as covalent nature, but ionic nature is dominant. That's all. Covalent molecules will have covalent bond as well as ionic bond, in which covalent nature is dominant. That's all. Therefore, anything we can consider. So now bonded molecules we have considered. In the bonded molecules, for example, we will consider hydrogen molecule. Sir, one hydrogen atom combining with another hydrogen atom to form hydrogen molecule. One hydrogen atom combines with another hydrogen atom to form what, in the sense hydrogen molecule. Okay. So how this hydrogen molecule is formed, that we will see. Now for this hydrogen atom, it is a nucleus. This is a 1s1 electronic configuration. It is 1s1 electronic configuration. For this hydrogen, it is a nucleus. This is a 1s1 electronic configuration. For this hydrogen, it is a nucleus. It is 1s1 electronic configuration. For this hydrogen, it is a nucleus. It is 1s1 electronic configuration. When the two atoms come closer, they will form hydrogen molecule. And that means these two coming closer, then they will be in, the electron clouds will be in contact. Then electron clouds a little penetrate with each other. That is called overlapping. Now it is a one electron cloud of one atom. It is a another electron cloud of another atom. Now here nucleus, here nucleus. This is a overlapping part. This overlapping part, in the sense in this part both their electron clouds will be there. This electron cloud will attract both nuclei simultaneously. Both nuclei attract this electron cloud. Therefore, both atoms combined with each other. Therefore, it is called a molecule. Sir, in this molecule, this is called what, in the sense this is called a bond. This bond contains, we can say, two electrons. This bond contains two electrons. This bond is called a covalent bond. Sir. Now, in this bond, two electrons present. Sorry. Now, we can say in this bond, two electrons present, that two electrons will give like this. Now, this nucleus attracts this bonding electron cloud. That means this nucleus in the sense this atom nucleus pulls this bonding electron cloud towards itself. Simultaneously, this nucleus attracts this electron cloud, which means this nucleus pulls this bonding electron cloud towards itself. This nucleus pulls this bonding electron cloud towards itself. Now we will see tendency. Now we will see the statement. Tendency of nucleus of a bonded atom, tendency of nucleus of a bonded atom to pull the bonding electrons, towards itself. towards itself is called electronegativity of that atom. So, tendency of this nucleus to pull this bonding electron cloud towards itself is called its electronegativity. Similarly, tendency of this nucleus to pull this bonding electron cloud towards itself is called its electronegativity. Now, both are hydrogen atoms. Both are hydrogen atoms in the sense both nuclei have same tendency to pull the bonding electron cloud towards themselves. Therefore, electron cloud, this bonding electron cloud will be equally shared by both, because both have equal tendency to pull. Both nuclei have equal tendency to pull the bonding electron cloud towards themselves. Therefore, this bonding electron cloud will be shared equally by both. So, now this hydrogen electron cloud and this hydrogen electronegativity will be equal in this case. Electronegativity of these two atoms are equal. Therefore, this bonding electron cloud is equally shared by both, we can say. Sir, now we will take another molecule. One is called H, another one is called F. For this H, nucleus will write its electron cloud will write, that is 1s1, which is valence shell electron configuration. For fluorine, nucleus we are writing its valence shell unpaired electron is 2p. Its valence shell unpaired electron is 2p. That 2p we will write. This 2p contains unpaired electron 1. 2p is Z1, suppose. Both atoms come closer and form molecule, that is HF. That means both electron clouds overlap with each other. This is hydrogen 1s1. This is 2pZ of fluorine. It is a nucleus of fluorine. Now electron clouds are overlapped with each other. It is called bond. Bond is produced. Okay. Now it is a nucleus of hydrogen. This nucleus of this hydrogen pulls this bond pair towards itself with some tendency. That tendency is called electronegativity of hydrogen in HF. This fluorine nucleus have some tendency to pull the bonding electron cloud towards itself, that is called electronegativity of fluorine. So this nucleus has some tendency to pull the bonding electron cloud towards itself, that is called electronegativity of hydrogen. This nucleus has some tendency to pull the bonding electron cloud towards itself, that is called electronegativity of fluorine. Now you say how the tendency of these two will be there of pulling the bonding electron cloud towards themselves. Will it be same or different? Sir, that if you see the nature of hydrogen and nature of fluorine is quite different. Hydrogen coming under first group, fluorine coming under 7th A group. So certainly their electronegativities will be different. Sorry. In most of the compounds, if you see, hydrogen shows charge +1. In most of the compounds, fluorine shows -1. In most of the compounds, hydrogen shows +1. Hydrogen shows even -1 also. Hydrogen can show even -1 charge in some compounds, but mostly it shows +1. Fluorine mostly shows -1. Mostly what? Fluorine can show only -1. It cannot show positive. It cannot show plus oxidation state. It can show only -1, that's all. Fluorine molecule, if you take, here 0. Charge is 0. Otherwise, compound means fluorine will show -1. This evidence says that fluorine nucleus has more tendency to pull this bonding electron cloud towards itself than that of hydrogen. So electronegativity of fluorine is greater than that of hydrogen. Okay, this experimental evidence says that electronegativity of fluorine is greater than that of hydrogen cell. So now we said electronegativity of fluorine is greater than that of electronegativity of hydrogen cell. Now this H and F we will take. This electronegativity of hydrogen we will take, that value is 2.1. Electronegativity of fluorine we will take, that value is 4. So now this fluorine nucleus has some tendency to pull the bond pair towards itself. That tendency is called electronegativity, that is 4. Now hydrogen has some tendency to pull the bond pair towards itself. That tendency is called electronegativity, that is 2.1. So which is having higher electronegativity means fluorine. Therefore this bonding electron cloud is shared more extent by fluorine and less extent by hydrogen. So this bonding electron cloud goes for unequal sharing. Which takes more share? Fluorine. Which takes less share? Hydrogen. That means it is less share in the sense for this loss in the sense loss of what? Electron cloud. So we have to give partial positive charge for hydrogen. For fluorine it shares to more extent. That means for this gain of electron cloud in the sense we have to give partial negative charge. So for fluorine we are giving partial negative charge. For hydrogen we are giving partial positive charge. So for this molecule one end contains positive, one pole contains positive charge, another end contains negative charge, another pole contains negative charge. Therefore it is called what in the sense dipole. Di in the sense two. How many poles? Means two poles. One pole is positive pole, another pole is negative pole. Therefore it is a dipole. Therefore it is called a polar molecule. Polar molecule. So this HF in HF polarity is there. HF is called dipole molecule. Why it is a dipole molecule? Why it is polar molecule? Why this bond is called polar covalent bond? Because hydrogen and fluorine have different electronegativities. Therefore this bond is going for unequal sharing. Fluorine takes higher share when compared to hydrogen. Therefore such a type of polarity is arised. Sir, so now what is electronegativity? We came to know it. Now whether electronegativity is a periodic property or not. What is periodic property? Periodic in the sense gradual change, regular change, that's all. If the property changes regularly or gradually down a group or along a period, then that property is called periodic property. So if electronegativity gradually changes down the group or gradually changes along the period, then electronegativity is called a periodic property. That's all. Sir, now whether it is a periodic property or not, that we will check it. Sir, now we will take a group. We will take any one group. We will take, for example, alkali metals. We will take alkali metals in the sense first group. In the first group, what is there? Lithium, sodium, potassium, rubidium, cesium, and francium. It is first group. Alkali metals is the first group. In the alkali metals, what are the elements are there? Means these are the elements are there. Sir, now lithium. Lithium electronic configuration is what in the sense 1s2 2s1. Lithium electronic configuration is 1s2 2s1. Now we will take a lithium chloride. Lithium chloride we will take. Then sodium configuration. Sodium configuration is 1s2 2s2 2p6 3s1. For this example is sodium chloride we will take. Now Lithium nucleus. Lithium nucleus has some tendency to pull the bonding electron cloud towards lithium. This sodium nucleus is having some tendency to pull the bonding electron cloud towards itself. Now, lithium is having 2 shells, whereas sodium is having 3 shells. So, for lithium, nucleus and bonding electron cloud distance is less. For sodium, nucleus and bonding electron cloud distance is more. Therefore, lithium is having more tendency to pull the bonding electron cloud towards itself than sodium. Therefore, electronegativity of lithium is more and electronegativity of lithium is less. This is one of the expectation. In this way, we expect electronegativity of lithium and sodium. Now we will see experimental result. So experimental result says electronegativity of lithium is 1, sodium 0.9, potassium 0.8, rubidium 0.8, cesium 0.7. It is electronegativity. So electronegativity of lithium is 1, electronegativity of sodium is 0.9. That means electronegativity from lithium to sodium decreases. That's what here expected. So that means in order to explain the electronegativity of lithium and sodium, we can use this one. Here lithium number of shells 2, sodium number of shells 3. So distance between nucleus of lithium and bonding electron cloud less, distance between nucleus of sodium and bonding electron cloud more. So lithium is having more tendency to pull the bonding electron cloud towards itself than that of sodium. So lithium is having higher electronegativity than that of sodium. Okay, this explanation we can do. Sir, down the group, how the electronegativity varies. That we'll see. Electronegativity from lithium to sodium decreases 0.1. Sodium to potassium decreases 0.1. Potassium to rubidium, some abnormal. Rubidium to cesium decreases 0.7. So superficially, if you see, electronegativity decreases down the group. Electronegativity decreases down the group. Therefore, electronegativity is a periodic property. Electronegativity is a periodic property, we will say. Okay, sir. So, electronegativity is a periodic property. Down the group, what happens means electronegativity decreases, we said. Sir. Along the period, how it will be there? Along the period, how the electronegativity will be there, that we will see. So, along the period in the sense, for example, we will take second period. We are taking second period. In second period, how the electronegativity will be there, that we will see. Okay. So lithium, we will take lithium electronic configuration is 1s2 2s1. Beryllium electronic configuration is 1s2 2s2. Boron electronic configuration 1s2 2s2 2p1. Like this, carbon, nitrogen, oxygen, fluorine, neon. Like this is there. So now we will see along the period in the sense number of shells remains same. Along the period in the sense number of shells remains same. Then we'll see effective nuclear charge. Effective nuclear charge along the period increases. Effective nuclear charge along the period what happens means increases, you can say. Effective nuclear charge increases along the period. So, effective nuclear charge increases in the sense size decreases along the period. Size decreases in the sense distance between nucleus and bonding electron cloud decreases, then tendency to pull the bonding electron cloud towards itself increases, therefore electronegativity increases. Okay, here see, effective nuclear charge increases, size decreases. Size decreases means distance between nucleus and bonding electron cloud decreases. So tendency to pull the bonding electron cloud towards itself increases, rising. So electronegativity rises. So it is one of the explanation Whether it is correct or wrong, that we will see using experimental result. Okay. Now, what experimental result says, we will see. Electronegativity of lithium is 1, beryllium is 1.5, boron is 2, carbon is 2.5, nitrogen is 3, oxygen is 3.5, fluorine is 4. Neon is exception, noble gas, not reacting. It is not going for any reaction. It is not forming any compounds. It has not formed any compounds so far. Therefore, electronegativity is 0, we can say, because no compounds are discovered so far. So neon we will leave it. Remaining we will take. So lithium 1, 0.5 we are adding, beryllium 1.5, 0.5 we are adding, boron 2, 0.5 add, carbon 2.5, 0.5 add, nitrogen 3, 0.5 add, oxygen 3.5, add 0.5, fluorine 4. Set. We got electronegativity like this. So how the electronegativity is there along the period, you see? Is it changing gradually? Sir, in this period, electronegativity changes gradually with some exceptions. Exceptions in the sense, neon, if you consider, it is 0. So, superficially, if you see, electronegativity along the period changes gradually. Therefore, the electronegativity is a periodic property. Sir. So, what happens to the electronegativity along the period in the sense, along the period it increases. Down the group it decreases. Sir, okay. So what is meant by electronegativity we got. Next we will go for how to determine electronegativity, how to find electronegativity. For finding electronegativity, one of the scale is called Mulliken scale. One of the scale is called Mulliken scale. Using Mulliken scale, what we can find in the sense, electronegativity we can find. So how Mulliken finds this electronegativity? For finding electronegativity, Mulliken considers ionization energy of an atom, ionization energy of an atom, and electron affinity or electron gain enthalpy of an atom. Mulliken considers ionization energy and electron affinity of an atom to find electronegativity of that bonded atom. So to find the electronegativity of the bonded atom, Mulliken considers that atom ionization energy and electron affinity. Why is it so? That we will see. For example, we are considering one atom called hydrogen. It is having one electron, that you know, 1s1. If you remove that electron, it becomes H plus 1s0. If you remove that electron, that is going away. For that you have to give energy. That energy is called ionization energy. This ionization energy is nothing but attraction between this nucleus and this electron cloud. Okay, this ionization energy is nothing but magnitude of attraction between this nucleus and this electron cloud. Correct? Sir. Now, we will take hydrogen. Its configuration is 1s1. It takes one electron from outside and becomes H minus. Configuration is 1s2. Now, in this process, what is the energy involved? That is called the electron affinity or electron gain enthalpy. Okay, so this electron gain enthalpy, this energy magnitude indicates that what is the attraction between this nucleus, its nucleus, and incoming electron. That means net attraction, because some repulsion also there, because this 1s1 electron will repel this incoming electron. So net attraction it says. Therefore, this electron gain enthalpy or electron affinity, this electron affinity reveals that the net attractive force between this atom and this incoming electron. Now we will consider a bond. We will consider, for example, HF. In HF, how many bonds are there? Means one bond is there. That bond is called covalent bond. For the formation of this bond, hydrogen is contributing one electron from 1s1. Fluorine is contributing one electron from 2pz. Therefore, this electron is contributed by this hydrogen. As per quantum mechanics, we should not say this electron is contributed by hydrogen, this electron is contributed by fluorine, because we cannot say the position of electron. Mathematically, we can say that is probability only, we can say. For understanding only, I am saying this electron, that electron like this. Okay. So this electron is contributed by hydrogen, and this electron is contributed by fluorine. Now, this nucleus, this hydrogen nucleus is attracting its own electron. That magnitude of attraction is nothing but ionization energy. Hydrogen nucleus is attracting the incoming electron provided by this fluorine, that is 2pz. This magnitude of attraction is nothing but electron gain enthalpy, isn't it? Now, what is electronegativity? Tendency of this nucleus to pull the bonding electron cloud towards itself. That is electronegativity. Now you say, is there any relation between electronegativity, ionization energy, and electron affinity? Yes, of course, is there. So, what is electronegativity means? Electronegativity is nothing but the average of these two forces of attraction. Average of these two forces of attraction, that is said by Mulliken. So Mulliken considers that average of these two forces is nothing but electronegativity of bonded atom. That means Mulliken considers electronegativity depends on ionization energy and the electron affinity of bonded atom. That is of course correct. Electronegativity means what? Tendency of this nucleus to pull the bonding electron cloud. Ionization energy is nothing but this nucleus and 1s1 electron cloud. Electron gain enthalpy means this nucleus and 2pz electron cloud. That electron gain enthalpy means what? It has to take this electron completely. That is only called electron gain enthalpy, no? But in this bond, is it taking this electron completely? It is sharing only, no? Then electronegativity depends on electron affinity, but not completely. So electronegativity is average of these two, is not exactness, is not having exactness. Because electron gain enthalpy means what? Taking electron completely. That is called electron gain enthalpy. But here this nucleus is pulling this electron, but it has not taken completely, no? Then how electronegativity depends completely with the electron gain enthalpy? Exactly average, how can we say? Therefore, it is Mulliken's thought is electronegativity is average of ionization energy and electron affinity, but it is not having exactness. Sir. So, as per Mulliken's thought, we have considered electronegativity is equal to average of ionization energy and electron affinity. We considered as per Mulliken. Sir. Now we will see another scale. We will see that another scale is called Pauling scale. How this Pauling scale considers, that we'll see. How the Pauling scale deals about electronegativity, that we'll see. How this Pauling scale deals about electronegativity, that point we'll see. Set. Now we'll consider as per Pauling scale. Pauling scale is based on bond energy. Pauling scale is based on bond energy. So what is bond energy? We'll see. Then we'll continue this Pauling scale. Now we'll take this hydrogen. This hydrogen is having 1s1 electronic configuration, that we will write 1s1 electronic configuration. It is nucleus. It is 1s1 electronic configuration of hydrogen. Next to fluorine, its valence shell electronic configuration is 2pz1. Here nucleus, it is 2pz1. 2pz1 we said. Now hydrogen combining with the fluorine. Hydrogen combining with the fluorine to give what in the sense? Hydrogen fluoride. Here how it is there in the sense hydrogen nucleus, the 1s1 like this. 1s1 like this. Then fluorine nucleus, then 2pz1 like this. 2pz1 like this. Next, the two electrons we can write like this. The bond contains two electrons. The two electrons we have written like this. Okay. Now see, this bonding electrons is attracted by both nuclei and vice versa. So since attraction is there, therefore they are united with each other. Now, in order to separate them, in order to separate them. That means hydrogen is separate, fluorine is separate. In order to separate them, we must supply energy. So we must supply energy to separate them. Separate them. This electron should go to this side. This electron should go to this side. In order to separate them, we have to supply some energy. That energy is called bond energy. It is, we are saying definition superficial. Sir. So bond energy in the sense we are separating these two bonded atoms. These two bonded atoms we are separating. So this energy we are considering as a bond energy. We got it. Sir, what is bond? Therefore, the bond energy tells that magnitude of attraction between these two, shall we say? So magnitude of attraction between these two atoms is called bond energy. Okay. Sir, so bond energy is nothing but a magnitude of attraction between these two atoms. Sir, now we will consider. Now we will take hydrogen molecule and a fluorine molecule. Hydrogen gas consists of hydrogen molecules. Fluorine gas consists of fluorine molecules. When on combining these two, they are going for reaction and giving a hydrogen fluoride gas. Hydrogen fluoride gas we have considered. Now, how the chemical reaction takes place, that we'll see. We have mixed hydrogen gas and fluorine gas. Hydrogen gas consists of hydrogen molecules. Fluorine gas consists of fluorine molecules. On mixing, they are combining to give what in the sense hydrogen fluoride molecules. Hydrogen HF gas is produced. Sir, now we will consider a hydrogen molecule. We can consider like this. We can consider hydrogen molecule like this. This hydrogen molecule during reaction dissociates and converts to hydrogen atoms. Okay, this hydrogen molecule dissociates into hydrogen atoms during reaction. Similarly, fluorine molecule dissociates into fluorine atoms during reaction. After dissociation, they are rearranging themselves. Hydrogen goes towards fluorine. Hydrogen goes towards fluorine and makes a bond. So, in this reaction, what are the process involved means bond breaking and bond formation. Correct? Bond breaking takes place and bond formation takes place. Sir. Now we will see bond breaking. This for breaking this bond, energy is required. That is bond energy of H2. That bond energy of H2 we will take. Okay. So we are taking a bond energy of H2. So bond energy of H2 we are taking. Then we will take a bond energy of F2 we will take. Bond energy of F2 we will take. For a now bond energy of F2 we have taken. Next, here bond is produced. So bond energy of HF we will take. Bond energy of HF. Here 2 times, therefore we will write 2 times. Otherwise, you do it multiply, divide by 2. Like this you take. Otherwise, you take this, you multiply this by 2. Sir. Now you say that here energy required. Here also energy required for breaking the bond. Sir, energy required for breaking is how much in the sense this much. Here bond is produced, therefore energy is liberated. Therefore here energy is liberated. Here energy liberated, exothermic. Here energy absorbed, that is endothermic. Now you say, what is the net energy change? Net energy change in this reaction. That if you want, you do like this, we will get net energy change. Okay, we will get a net energy change. We will get, isn't it? Sorry. So here we are getting what in the sense net energy change we will get it. Sorry. If net energy change is 0, if net energy change is 0, then we can say energy of HF is equal to 1 by 2 into energy of H2 plus 1 by 2 into energy of F2. Okay. If net energy is 0, then we can say like this. Sorry. Now we will see this in a geometric mean we will take. Now same thing in geometric mean we will take. Geometric mean in the sense energy of bond energy of HF is equal to bond energy of H2 into bond energy of F2 square root. In geometric mean we have considered. Sorry. So bond energy of HF is equal to square root of bond energy of H2 into bond energy of F2. So now we will see experimental result. Experimentally we will find HF bond energy. It is experimentally found HF bond energy. Experimentally we will find HF bond energy. It is calculated. It is calculated. This value we got by the assumption of what? Net energy change is 0. This assumption we took. As per this assumption only, we said energy of calculated, this bond energy of HF is this much. Okay. So bond energy of HF calculated value we got by taking what assumption you know. Now bond energy of HF experimental value we are getting. So we know HF bond energy experimental and calculated. Now how these two magnitudes will be there, that we'll see. So experimental bond energy of HF and calculated bond energy of HF. Calculated bond energy of HF. Experimental bond energy of HF and calculated bond energy of HF. These two will be equal. It is one possibility. Another possibility, this experimental value is greater than this calculated value. This is one possibility. Another possibility is experimental value is less than calculated value. Calculated value. These two values we have compared. The experimental value and calculated value we have compared. They are coming like this. So, which possibility we have to consider out of these three? That we will see. Now, hydrogen molecule will see. Electronegativity of both hydrogen atoms are same. The electronegativity of these two bonded atoms are same because both are hydrogen. Then this bond is equally shared. Equally shared we can say. This bond is equally shared. That means here what is the dominant nature in the sense covalent nature. Similarly here also both atoms are same. Therefore the bonding electrons clouds are equally shared. Bonding electron clouds are equally shared. Therefore this bond is having covalent nature. This bond is having what nature means covalent nature. Now we will see HF. You know that electronegativity of H and fluorine are different because they are different atoms. Therefore, the bond is unequally shared. The bond is unequally shared. Unequally shared in the sense, here, what nature automatically comes in the sense? Ionic nature comes automatically. Ionic nature comes automatically. And also covalent nature is there. And also covalent nature is there because hydrogen and fluorine going for bonding in the sense by overlapping only they are going for bonding. Therefore, here covalent nature is there. So in HF, covalent nature is there as well as ionic nature is there. Here what nature is there means covalent nature, covalent nature. Now we will say this